The whole computing industry is built on 4 functions: data input, data processing, data output, and data storage. SQL establishes the ability to use all 4 of these functions, which is why it's so popular and is used by such a wide range of applications from small websites to large enterprise systems. So what is SQL? SQL is a programming language. It stands for Structured Query Language, and it's used to manage data stored in relational databases. A relational database is a type of database that organizes data into different tables that are linked using relationships. In a relational database, each table consists of rows, or rather records, and columns known as fields. The values in the columns are used to identify and access the data in the table. Databases link these attributes and their relationships using 2 types of key: primary and foreign. In a database, a primary key is a field or set of fields that uniquely identifies each record in the table. This means that for any given table, there should be no 2 records with the same value for the primary key field. The purpose of the primary key is to ensure the uniqueness and identify each record in the table, so that it can be easily accessed and updated. For example, in a table of customer information, the customer ID number or name should be used as the primary key. If a table in the database does not have a primary key, it can lead to several issues. If a primary key is not unique, 2 or more records may be returned containing incorrect information, or worse, personally identifiable information for someone else. Another issue is inconsistency that comes from not having a primary key. It's possible for 2 records to have different values for the same field. For instance, if a bank has 2 customers with the same name, it might get their financial records muddled up with the other person with the same name. This can lead to inconsistencies and confusion when accessing and updating records in the table. Lastly, it can lead to a lack of relationship. It can be difficult to see what belongs to who and where it should be. In a database, a foreign key is a field that's used to link 2 tables together. It's a reference to the primary key of another table and is used to establish a relationship between the 2 tables. For example, if we have a table called orders that has a foreign key referencing the primary key of a table called customers, this would establish a relationship between the 2 tables that indicates that the orders table contains information about the orders placed by the customer in the customers table. This is all well and good for trying to understand relational databases. But what does SQL have to do with this? Well, SQL is used to perform a wide range of operations on the database. In this example, we're creating a table called customers, with fields that you'd expect to be in the customers table. If we want to add another field, we can alter the existing table to include new fields. Adding records is also quite simple in SQL, and can be used to update existing records in the table. We can delete existing data, and even the whole table if required. The query language also provides powerful tools to help you sort, filter, and aggregate data. To give you an idea how SQL works, let's look at a simple example. Suppose we have a database that stores information about employees in a company, including their name, age, and salary. With SQL, we can use the select statement to retrieve specific data from the database. For example, we could use the following query to get the names and salaries of all employees who are under 30 years old. Here, we're selecting the name, salary, and age fields from the employees table, where age is under 30. This would return a table with the names and salaries of all employees who are under 30 years old. If we were to draw a relationship between 2 tables, the query might look something like this. In this example, the employees table has a foreign key called department ID that references the department ID primary key in the departments table. This query uses an inner join to combine the 2 tables and retrieve the name field from the employee table and the department from the departments table. The on clause specifies the relationship between the 2 tables using the department ID field. This query would return the result with the name of each employee and the name of each department they work in, showing the relationship between the employees and the departments they belong to. SQL is a very powerful and versatile language that allows you to manage and analyze data in a structured and efficient way. It's an essential skill for anyone working with databases, and it's widely used in many different fields from finance and business to science and engineering. SQL is a standard language that is supported by many different database systems such as MySQL, PostgreSQL, and Microsoft SQL Server. This means that you can use SQL to access and manipulate data in a variety of different systems without needing to learn a different language for each one, though each flavor of SQL has its own caveats and deviations in syntax. SQL is a declarative language, which means that you specify what you want to do rather than how you want to do it. This makes it much easier to write and understand SQL queries, as you don't have to worry about the details of how the data is organized and accessed in the database. SQL is a widely used and documented language with a large and active community of users and developers. This means that there's loads of resources available to help you learn SQL and solve any problems you might encounter, such as tutorials, forums, and Stack Overflow. I hope this brief introduction to SQL has been helpful. I'll be making future videos delving deeper into the security aspects of SQL, such as SQL injection, authentication bypass, and union injection. If you'd like me to do a video on a topic you're struggling to understand, please let me know in the comment section.